right, in this lesson we are going to look at linear equation word problems, so certain types of word problems that would represent linear data and therefore would allow us to write the equations for those as lines. So when you're looking at any kind of linear equation word problem, you're going to look for certain things. One of the following must be given to you. So the first scenario is you might be given your slope and a point in the word problem. So one of the points that would fall in that linear set of data and the slope. And your slope will be referred to as a ratio or rate, as we've already seen. So you're looking for things like $5 per book, or $3 each, or 5 cats per day. I don't know. Something like that would be a rate and would indicate your slope. The next scenario is you might be given your y-intercept along with a point in the data set. So the y-intercept, remember, refers to the start or beginning amount or value in the scenario. You could also be given 2 different points in the data. So if you're given the 2 points from there, you could calculate your rate or slope. And the last scenario is you might be given the slope and a y-intercept, so a rate and a starting amount. So let's look at some examples. Oh, sorry, forgot one little thing. Our slope is going to be really helpful for us today and throughout this unit in helping us determine which variables are representing x and y represent. So for example, if we are given the rate 15 miles per hour, we can rewrite that as 15 over 1. So 15 miles per hour, if we know that to be our slope, and if you'll remember, slope is equal to the change in y's over the change in x's, then when we write our slope, right, 15 over 1, in this way here, 15 miles over 1 hour, that tells us that the units for the numerator would represent the y value throughout the word problem. And the unit for the denominator coincides with our x variable. So here we could immediately tell that y stands for miles and x stands for hours. So anytime you're in doubt about what x and y stand for, turn to your rate to determine what they are. The y's will always be in the numerator. So the 15 is on top, so miles would be your y, and the 1 is on the bottom. It wasn't written that way, but any number is understood to be 1, so that implies hours or time. Okay, so now let's look at an example. In this example, it says the Band Boosters are selling submarine sandwiches for $5 each. The cost of ingredients to make the sandwiches was $1,160. And we're going to write an equation for the profit, P, on S sandwiches. So this means instead of using X and Y, we're going to use P and S. So generally in a scenario like this, what I do is I work through the problem using X and Y, and then at the end I replace X and Y with P or S in this scenario, for example. So let's identify what we're given. So we have some numerical values in the word problem, the first of which is $5 each. Hopefully you recognize that that is a rate, $5 each. It's $5 per sandwich. So every sandwich they sell, they're making $5 or charging that much. So that is a rate, which would then be a slope. So that's our slope. And the cost of the ingredients to make the sandwiches was $1,160. This represents a starting amount. So let's break down those pieces. So we're given a slope and a y-intercept, that starting amount. Oops, let me jot down real quick. If our slope is $5 each, we can rewrite that as $5 for every 1 sandwich. I'm going to do this with units to help me identify which variable is which. So if this is my slope, and I have change in y's over change in x's, then I hope you can see that the y variable represents the cost or dollar amount, and the x variable represents the sandwiches. It's really important to identify this at the beginning. Like I said, we'll be replacing those with P and S later, but it will also help us throughout the problem in setting up our equations. So if we're given a slope and a y-intercept, it's important to now ask ourselves which linear equation form would be best to write our equation in. Hopefully you're seeing a slope and a y-intercept would nicely transition to slope-intercept form, which would be y equals mx plus b. So we will fill in our slope of $5 each as m, and our b represents the starting amount. So let's investigate that a little bit further. When we're thinking about this starting amount being $1,160, we need to determine, is that a positive or a negative in this scenario? And that's where it helps to focus in on the variables we'll be using. So we're being asked to represent P, to have P represent our profit. So a profit is an amount, hopefully, that we're making. It's an amount we're making based on the amount we've had to spend on other ingredients or whatever it costs to make the sandwich. This is generally, if it's a positive, that's a really good thing for a profit to be positive because you are making money. So if the ingredients cost us $1,160, that's not helping us make money. That's the band boosters having to spend money just to get all of the ingredients for these sandwiches. So that would represent a negative amount. So what you can think about is if they were to sell 0 sandwiches, they technically are in the hole, that you could use that expression, $1,160. So it's really a negative $1,160. They don't start making money until they've sold enough sandwiches to make back the money they've spent buying all of these ingredients. So when we put $1,160 into our equation, it's going to go in as a negative. And I should, that wasn't supposed to be an S, use y and x first. Oh my goodness. Y equals, I can't talk and write, 5x minus 1,160. And so this would be our slope-intercept form equation. We need the slope to be $5 per sandwich. We also know that x represents sandwiches, and then the negative 1,160 starting amount. And if we know that y is dollar amounts, we can also think of y as our profit. So that's how you could determine P equals 5S minus 1,160. Oh, I'm revealing too much. Okay, and then the follow-up question, what would be the profit if 1,400 sandwiches were sold? So if we're selling 1,400 sandwiches, and we've properly set up our equation, we could clearly see that we would put 1,400 in for S because S stands for sandwiches, and simplify to find that it would be $5,840. Now, you certainly could argue that at some point this equation would no longer make sense because they would run out of those ingredients that they had purchased to make all the sandwiches. So for what we're doing, we're focusing on the portion of that equation. If we were to actually graph this, that would represent their profits until they were to run out, for example. All right, so in this problem, we were given a rate, a slope, and a y-intercept. So a slope and a y-intercept, and we were able to write it in slope-intercept form. Let's look at another. Here's our next example. Leah and her friends rented a canoe for 3 hours and paid a total of $45. The rate for canoe rentals is $10 per hour. Right there, we're told rate. So that's a hint that $10 per hour is our slope. Okay. We're to write a linear equation to find the total cost C of renting the canoe for H hours. So let's focus in on what we're given. We already identified that we're given a rate or a slope. And from that slope, we see it's $10 per hour. So this tells us that Y's variable is money and X's variable is time or hours. Next, we read, well, actually, if we back up, we can see that for 3 hours, they paid a total of $45. These two pieces of information come together to create a data point in this set of potential values that we could find for multiple different hours you could rent the canoe for. So we're actually given a point, and when you're setting up your point, if you have used your slope properly, you can see the hours should be X because we saw that in our slope. And the total of $45 is our Y because Y's variable was money. So I'd write this as 3, 45. Generally, points are given to you in order in a word problem of X, Y. So in a scenario where you weren't given the slope, it would be given to you in order of X, Y. X first, then Y second. Here we did have the rate, so we could confirm that we did have the X value as the hours and the Y as the money. So we are given a point and a slope. Therefore, hopefully you're recognizing that if we have a point and a slope, then point-slope form makes the most sense for us to write our equation in. And remember, point-slope form is y equals y, or y minus y1 equals m times x minus x1. And if you have your values properly labeled, here our rate as m and our point, then we can fill into point-slope form. What we don't know, though, is the daily fee. So let me fill into point-slope form real quick. So our y1 value is 45. Our slope is $10 per hour, so just 10 over 1 is 10. Okay, so this is the equation in point-slope form. What we don't know, though, is the starting amount. So in order to find the starting amount, or that one-time fee, we could pull that if we had it in slope-intercept form. So the B value would tell us that one-time fee for renting the canoes. So what we can do now is transform from our point-slope form equation to slope-intercept because we need our y-intercept. So to do this transformation, we would distribute first and then add the 45 to both sides. Oh, and I didn't realize I already showed it there. And this would bring us to y equals 10x plus 15. Now notice I'm still using the variables x and y. So I will need to change those to C and H, but we have identified how much that one-time fee is. This 15 is our B value, our y-intercept, so that tells us that even to rent the canoes at all, you'd have to spend $15, and then on top of that, the rate of $10 per hour. So we would write this in slope-intercept form, and we'll finish, we know y to be money or cost, and H to be hours. So that would have been our X. So we can replace C and H for Y and X, giving us the equation C equals 10H plus 15. All right. Moving on to applying this a little bit. If we were asked, so all that, those two bullets at the top are just reviewing and repeating what was on the last slide. But here, down here, how much would it cost to rent the canoe for 8 hours? So now we're using our equation we wrote to actually apply it a little further and calculate a different point, really, is what this would be on the line. And so the point we want is how much would it cost for 8 hours? Well, if we are looking for 8 hours, then we would replace our H with 8 and then solve, and that will give us the output C, our cost. So replacing that, 10 times 8 is 80, plus 15 is $95. So it would cost $95 to rent this canoe for 8 hours. So a lot of times what we'll do is not only write our linear equations for these word problems, but use them to find other information about this, find out other information about the scenario. All right, moving on to the next example. In a certain lake, a 1-year-old bluegill fish is 3 inches long. while a 4-year-old bluegill fish is 6.6 inches long. Assuming that the growth rate is always the same, so that's saying assume that a fish never plateaus at a certain length, write an equation for the length L of a bluegill fish in inches after T years. So that's telling us what variables to use instead of X and Y. Now when we go and read, and we're reading this problem, one thing you should always look for is a rate when you're reading. So reading along here, we're not really seeing a rate given to us. We're not told like how much per month or year or how many inches per anything. So because we're not given a rate, that's an indicator that we probably are given 2 points, maybe a starting amount, but we also don't see a starting out length for the fish. So that should lead us to believe that we are given 2 points. So the first point, hopefully you can see, 1-year-old bluegill fish is 3 inches long. 1-year-olds are 3 inches, so 1 and 3 go together to create a point. And then a 4-year-old fish is 6.6 inches long, so 4 and 6.6 should create your second point. So we are given 2 points. And it would be helpful, remember I told y'all just a little bit earlier that these are often given to you in order if you're not given your rate. So if we know that time is 1 and 4, I could label those as my T's, and then the lengths L. This gives us an idea of the X and Y values. Okay, so the Y's come second, right, in our points. All right. So if we're given 2 points and we want to write the equation of the line, we absolutely have to find the slope of this line first. So for this data. So what you should do now is work to find your slope, but you need to pay attention to the fact that there is a decimal in this problem. So our slopes should never have decimals in them when they're finished being written, because they are rates, and rates compare to whole or integer values. So calculate your slope and get rid of decimals, and let's come back together and check in a moment. So click pause, find your slope, and you're ready to check. Click play. Okay, finding your slope. You should have found it to be 6/5. So subtracting your y's in the numerator, subtracting your x's in the denominator leaves you with 3.6 over 3. Multiply that fraction by 10 over 10. Remember, that's really just 1. Anything divided by itself is 1, and anything times itself is 1. That's why we're allowed to do 10 over 10. And that gives us 36/30, which reduces to 6/5. All right, from here we need to write the equation of our line. We now have 2 points and a slope, so point slope form would be the most natural scenario to set up from here. Remember, for point slope form you just need 1 point, so I am going to choose this point. You can choose either point. This one doesn't have decimals though, so that's going to make it a little bit easier for us. Remembering that L is our y variable and T is our X, and we identified that from the way the points were given. So go ahead, write your equation in point slope form using L and T. When you're ready to check that, click play after pausing. Okay, so L minus 3 equals 6/5 times T minus 1. Remember, this is your y minus y1 equals m times x minus x1. So replacing the 1, the m, and the 3. From here, we could then transform to slope-intercept form because we want this to be a form that we could calculate potential other time or length values and find that missing piece for any point on this line. So, or in this data set, I should say. So we will write these equations in slope-intercept form. So from here you would need to distribute and isolate your L. So take a moment to fully finish transforming to slope-intercept form. Okay. If you're not finished yet, make sure to pause and then check in a moment. But we would distribute first, giving us 6/5 t minus 6/5 right here. And then I chose to multiply through by 5 to get rid of all of those fractions that I have, but don't forget every single term has to multiply by 5. And then isolate your L, giving us the equation L equals 6/5 t plus 9/5. So this equation is helpful to us because if we wanted to find out how long a fish would be after year 5 or 6 or 7, all we'd have to do is replace t with that value we're curious about, and it would give us, when we simplify, the length of that fish. All right, there is one last word problem that I'm going to let you try on your own. So read it through, determine what information you're given, and then write your equation of your line, remembering that we will finish these in slope-intercept form to have the most useful form to us to be able to find missing pieces. All right, click pause when you're ready to check this problem. Click play. Okay, hopefully you identified that there were 2 points given to you. Again, as you're reading them in the order you're reading, it's giving you the x and y values for your points in order. That then tells you these points are written with the UK size first and the US size second. So that will help you get your slope, which hopefully you found to be 1. When you subtract your y's and subtract your x's, you get 1/2 over 1/2, which is 1. Okay, from here you should have used point slope form. That would have been the most straightforward form to go into. And I used the 0.5, 7.5 in point slope form and filled in the slope of 1 that we found. And then from here we distribute and transform to slope intercept form, getting that the US size equals the UK size plus 2.5. And that concludes our linear word problems lesson. So hopefully now you have enough practice and information to be able to write equations of lines from word problems.